Slopes of perpendicular lines. Now, perpendicular lines have opposite reciprocal slopes. So what does that mean? If I have one slope that is a over b, a perpendicular slope would be the opposite, so it's going to be a negative, and reciprocal. I'm going to flip that fraction over. So these two lines are perpendicular to each other, which makes sense. If one has a positive slope, to be perpendicular, the other has to have a negative slope. When I look at the rise and the rise of one is going to be the run of the other. The run of one is going to be the rise of the other. So I'm flipping that fraction. Determine whether sides AB and BC, this is the same one we worked with parallels, determine if they are perpendicular. Again, when we work with geometry, we always want to prove anything that we haven't been told specifically. So we're going to actually see if we can prove that those two are perpendicular to each other. So I'm going to take line AB, I'm going to take the 2 points that I've been given, and I'm going to find the slope, and I come up with a slope of 3/8. That's the same slope we found when we worked with parallel lines. I'm going to take line BC. I've been given 2 points on line BC. I'm going to find the slope. I come up with a slope of 2. Now, if I'm looking for opposite reciprocals, these are not even close. BC should be -2. Ah, there it is right there. I lost my negative. I lost my marker. Hang on a second. I'm back. So this should be a -2. 6 minus 8 is a -2. My slope should make sense. If I have a positive slope and a negative slope, those are lines that I might think are perpendicular. That's a negative slope there. So they're opposites of each other, but they're not reciprocals of each other. So these are not perpendicular lines. So AB and BC are not perpendicular because their slopes are not opposite reciprocals. If they had been opposite reciprocals, I could have had a -8/3. That would have been perpendicular. Or this one could have been 1/2, +1/2. That would have made them perpendicular to each other. But as they are not perpendicular to each other. All right, let's put this to work. Determine whether the graphs of 3x plus y equals 12, y equals 1/3 x minus 2, and 2x minus 6y equals -5 are parallel or perpendicular, and explain why. So I'm going to work with each of these equations one at a time. I'm going to take my 3x plus y equals 12, and I'm going to rewrite it so that it's in slope-intercept form, and find out that the slope is -3. My second equation, y equals 1/3 x plus 2, it's already in slope-intercept form, very friendly to work with. So I'm going to pull my slope right out of there. My slope is 1/3. My last equation is again in standard form, so I'm going to have to do a little work to find the slope. So I'm going to rewrite it in slope-intercept form, and I come up with a slope of 1/3. So I've got my three slopes here, -3, 1/3, and 1/3. They want to know, are any of these parallel or perpendicular? So I know that y equals 1/3 x plus 2 is parallel to 2x minus 6y equals -5 because they have the same slope. So these two have the same slope. They are parallel to each other. I also know that 3x plus y equals 12 is perpendicular to y equals 1/3 x plus 2 and 2x minus 6y equals -5 because they have opposite reciprocal slopes. So notice that my 1/3, the reciprocal of 1/3 is 3. The opposite of the reciprocal would be -3. So these are perpendicular to each other because they are opposite reciprocals. All right, last one. Write an equation in slope-intercept form for the line that passes through 4, -1 and is perpendicular to the graph of 7x minus 2y equals 3. All right, our original line, and I like to really break this up into what's my original line and then what's my new, in this case, perpendicular line. So my original line, I need to find the slope of it because what I know about perpendicular lines is they have opposite reciprocal slopes. I'm going to take this original line in standard form, ew, and I'm going to rewrite it so I have the slope. So there's my slope right here, 7/2. So I have a slope of 7/2. I also know the y-intercept, but that only applies to the first line. It doesn't necessarily apply to the second line. They're perpendicular, so they could have the same y-intercept. Chances of that are kind of slim, though. So I'm going to take my slope. For my new perpendicular line, I'm going to create the opposite reciprocal. So the opposite is negative, since this one's positive. Reciprocal, I'm going to flip it, 2/7. So this is my new slope of my perpendicular line. I'm forgetting everything else about that original line. They're telling me that the new line goes through 4, 1. So I have the slope and a point. I'm going to write myself an equation for that. Take my slope-intercept form. It starts to look like y equals -2, 7x plus b. Plug in that point that they've given us. We do the algebra, and we come up with a y-intercept of 1/7. So my equation is y equals -2/7 b. B, how about x, Ms. Mac? negative 2/7 x plus 1/7. So there's my equation for a perpendicular line to the original line that they asked us about.